In this example, we're going to end up doing two different videos for this, but in this first example, we're going to be focusing on where is this graph increasing and where is this graph decreasing. So right now, I have absolutely no idea. It's some sort of an exponential decay, but a linear kind of attached to it. I have no idea what it looks like. So we're going to try to figure out when it's increasing and when it's decreasing, which means we're talking about slopes. So let's do our derivative. And doing our derivative is finding us our slope equation. So if we do the derivative of this, we're going to do the derivative. We have a product rule going on. So it's the derivative of the first, which is 1 times the second, e to the negative x, plus the first times the derivative of the second. And so the derivative of an exponential is itself times the chain rule part of this times the derivative of the exponent, which is -1. So let's clean that up. So we're looking at e to the negative x minus x e to the negative x. All right, so there's our derivative. There's our slope equation. So we're trying to figure out when it's increasing and decreasing, which is positive slopes and negative slopes. So let's find out when we have a slope of 0, because that's when you shift from increasing to decreasing or decreasing to increasing. So we'll take this equation, we'll set it equal to 0, and we're going to solve it. So here's our equation, set it equal to 0. We can factor out an e to the negative x, which would leave us with a 1 minus x equaling 0. And then if we set each of these factors equal to 0, x equal to 0. If you remember, we have an exponential right here. We have an exponential decay. So visually, we have a graph that kind of looks something like this. And an exponential is never going to hit a 0. So there's no chance to get a 0 out of that piece of the equation. But this piece, we can get a 0 when x equals 1. All right, so there's our critical point. Next thing to do is test our sections. So we're going to plug values to the left. We're going to plug values to the right into this or this, but this is kind of easier because we can just look at signs here. I don't have to actually do the math. So if I plug in a value that's less than 1, such as a 0, we're looking at an e to the 0. And to be honest, I don't have to worry about the exponential at all because exponentials are positive everywhere, at least on this graph. So we're going to have a positive value of some kind times 1 minus 0 is another positive. So those two positives multiply together, it's going to be a positive. And then if we go to the right, let's plug in like a 2. This is still going to be positive. And then 1 minus 2 would be a negative. And those two multiply together to make negative. So visually, I don't know what this graph looks like. And not going to plug it in a calculator or anything. I don't need to, because this math is going to tell me everything I need. So we're just looking for when this graph is increasing and when this graph is decreasing. Well, it's increasing when your slope is positive. So our slope is positive from -infinity to 1. And it's decreasing from 1 to infinity. All right, so that was our first example talking about increasing and decreasing intervals. Next video is going to do the second example.